Tenancy in Kubernetes is evolving. It began with the introduction of namespaces, which provided organization, but not real true isolation. When you start dealing with cluster level resources like CRDs, things get a little more complicated. That's where things like vCluster come in. vCluster allows you to have virtual clusters for each of your tenants. And inside of each one of those clusters, you have your own API server, your own data store. You're able to manage your own custom resources without running into your other tenants inside of the host cluster. Now, what's been fascinating for us at vCluster is to watch the journey of our users and how they discover tenancy and to discover the things that they need and to discover how we can best help them. We can essentially organize their thoughts in the different modes into three different models. First is the shared node model. This is the most common model that people use vCluster for, that they provide multi-tenancy inside of their host cluster. In this model, each of the vClusters share the nodes of that host cluster. They decide which node is available, and then they make requests on that node, and everyone shares the same nodes. However, this does provide multi-tenancy. It doesn't provide isolation on some levels, namely the fact that they're sharing nodes, but also the fact that they're sharing things like CNI and CSI. Those things are also being shared in a shared node environment. So folks have been then asked for things like, okay, well, what about if we separate things a little bit more and have like a dedicated node situation? In these cases, you can associate a virtual cluster with a specific node or node pool. So in our case here in our diagram, we have tenant A is tied to the node A, and then tenant B is tied to its own node pool. That way nodes are separated and there's a bit more isolation going on in this side of this model. However, this doesn't provide true isolation because things like CNI and CSI, those are still being shared across the vClusters. So then we start thinking, all right, what if we provide private nodes? In private nodes, you have specific isolated nodes that are not seen or visible by any of the other virtual clusters inside the host cluster. And you're thinking, okay, this works out quite nicely because now things are quite separated and they're separated at the CNI and CSI level as well. And now in vCluster version 0.28, we're taking that private node concept one step further by introducing auto nodes. And in this case, we're utilizing Karpenter, which is a well-known, well-respected open source project in the community that's used for autoscaling. It's usually tied to specific environments. So in AWS and Azure, you can have their autoscaling functionality, but that's tied under the hood to Karpenter. Now we have Karpenter baked in to vCluster, so we can auto-provision nodes inside of your virtual clusters. The dynamic provisioning allows you to scale up and scale down based on the requirements of your pods. It also has multi-cloud support. You're not tied to a specific cloud or a specific environment anymore. You can run it on any cloud that you're running your clusters on. Even you can be running it on bare metal. And in this video, I'll show you how you can define your requirements in your vcluster.yaml file. Now think of using this auto node feature. Now you can think about reducing costs by not over provisioning your resources. You can say dynamically create me a node, run things on it, and then spin down that node automatically and dynamically. What I want to do is show you how auto nodes works and how you can set it up on your vCluster platform. But before we do that, I want to help you visualize what's actually happening behind the scenes. As mentioned, Karpenter is baked into the feature. And then as part of Karpenter, we have this idea of something called node claims. Node claims are a way of saying, I need to provision this type of node when you run this type of workload. vCluster will see the node claim and then try to fulfill it based on the node pools you specify for that vCluster. vCluster then communicates with your node manager, whether it's your cloud provider or your bare metal server, and then it provisions the node, either with Pixie Boot or creating a VM on that cloud service. And then after that node is created, it joins that node as a private node in your vCluster. Let's take a look in GCP how this is done. So looking at my Google Cloud dashboard, we can see that I already have a GKE cluster running here, and it has 3 nodes. Now I'll switch over to my vCluster platform, which has also been deployed into my GKE cluster. You want to make sure that you're running platform version 4.4.0, which was introduced in vCluster version 0.28. That will give you the features that we're looking for specifically with auto nodes. We want to first provision our node provider. And so we'll go down here to the infra section and pick nodes. We'll say create node provider. And here you'll be greeted by 4 quick start templates. These are essentially the 3 main cloud providers and then also KubeVirt. You can also come down here and pick from scratch if you want to create a node provider in Terraform. Anything that can be provisioned with Terraform, you can create a provider, a node provider here in the vCluster auto nodes feature. You can also integrate with NVIDIA's BCM or KubeVirt as well. You can create your own KubeVirt provider here. Today, what we're going to do is we're going to use the GCP Quick Start Guide. So I'm going to come here and I'm going to give it a really clever name like GCP Compute. I'm going to use the GKE Workload Identity Federation for authentication. That's outside of the scope, at least setting that up is outside of the scope of this demo, but you'll want to make sure that you have those necessary settings put together before you go through this process, and look at the GCP documentation to help you out there and to make sure everything's set. In this case here, I'm going to make sure that I have my project name. I'm going to select my region and then my zone. You don't have to select a zone. I'm choosing that for this time. If you leave this blank, it'll actually just default to your whole region. I'll create my GCP provider. And now with that node provider created, we can see the different instance types that we can have inside of that node. And see that these are the different types of GCP VMs that we can create when we are provisioning our nodes. And now that that's created, let's go create our vCluster. So to create my vCluster, I'm actually going to utilize a template. Templates are defined here, and I have an auto node template that I created previously. And I'll just want to show you that template real quick. In that template, I have a control plane that I'm defining with my service being a load balancer, but then my private nodes is that area here that's unique to us today. So we're going to enable that, the private nodes feature, and then we're going to set up auto nodes. They're going to be dynamic. We're going to use that GCP compute provider that we just created. And then when you create the various nodes, we want them to be very specific in this situation. We have a list here of values that we could put in here, and you can select any of the different types of instances that are available inside of your provider, whichever if your cloud provider uses those different instance types, you can list them here. So in our case here, I'm going to be very specific. I want an E2 standard 4, and then I want that with the 100 CPU and a 200 gigabyte of memory. Now we'll create our vCluster using that template I just showed you. So say create vCluster, auto node awesomeness. And then I'm going to use that template, and it gives us the values that we were talking about there. We can see that we have our instance type, one of the instance types that we showed in the provider. And then we have our private nodes enabled, our auto nodes will be dynamic. Okay, so we're going to create that virtual cluster here. And this will take a few minutes. Remember, we are creating instances on another system. So in this case, we are creating VMs on GCP. So it's going to take some time to line everything up and actually create those resources. While we do that, I'll explain what's going on. So the node provisioner uses Terraform and OpenTofu to create the nodes. Anything you can provision with Terraform or OpenTofu can be provisioned with auto nodes. And in each virtual cluster, there is an environment that it creates where it creates a VPC, creates a public subnet, a private subnet, a cloud NAT for all the subnets, and then also firewall rules for those worker nodes that it creates. And then for each cluster, it's going to create a compute instance of the instance type. Now, remember, we set that instance type in the vcluster.yaml file. All right, now we can see in our UI, we've attached a node. So now we can head over to Google, refresh that, and see that we have auto node awesomeness in our Google Cloud. But what about if we need more instances? Let's actually create a deployment inside of our cluster to see how we can do that. So let's go into our virtual cluster and create a deployment. So I'm going to come down here. Going to create a deployment. We'll call it deployment awesome. Give it a namespace. We'll give it some replicas. We'll say 5. We really want this thing to have a lot of compute. And we'll even add some resources here where we say, let's give it some CPU. Let's give each machine 2 CPUs, and we'll give that a go. We're already provisioning our pods here. Got 1 out of 5 going. You can look over here. We can see we have pods pending. And now let's go look at our Google dashboard. And there we see we have our 5 nodes, our 5 VMs running on our Google Cloud, dynamically created with our auto nodes. Now, what happens when we want to be done with these auto nodes or these nodes that were automatically created? We can go back to our deployment. And we can edit this to say, nah, we're just going to bring it back down to 1. We'll update that. And now we see our instances being decommissioned. So that's a brief introduction of what you can do with auto nodes using GCP. Remember, this isn't tied to any particular cloud. So you can run this in any of the cloud providers or on your own cloud or in your own bare metal environments. We're excited to share this feature with you. Let us know in the comments what you're excited to do with auto nodes, or if you have any questions, reach out as well. We have more exciting things coming from vCluster later this fall. In addition to auto nodes, we're also going to be introducing vCluster standalone, which will be able to run vCluster as its own Kubernetes distribution. So you want to keep your eyes open on our vCluster launch page and our launch section of our website, and check out our socials and make sure that you're kept informed of what's coming from vCluster. We look forward to hearing what you think. Leave a comment here on the video or join us in Slack at slack.vcluster.com.